I'm Darrell Aucoin. This is introduction on SQL. It's continuation of the previous one we had on Monday. Basically, we're going to go deeper a little bit into how to query in the SQL language. So, how many people here been to a previous SQL? The previous, most people. Okay, good. Yeah. Hopefully, for the rest of you, if you didn't, you at least know a bit of how to do things. So, because not really going into the select and how some of the basics of that we covered earlier. So currently for this one, we're going to basically tell you how to filter rows from a query and how to aggregate and join up tables, how to even use subqueries, which is really powerful, how to use set operations, and the with clause actually helps us out with readability. Case expressions helps transform variables and expressions into new columns. Order by and basically arranges clauses, and limits basically limits to the first so many rows or last so many rows. So following along, if you haven't already, download that from this link here, where it basically has the test database. Download zip file, unload it. This basically shows you where it has our test database for Stats Club, and also like examples of how things are going, examples of everything going along. Yes?
Is this supposed to be like presentation 1 or 2?
It's supposed to be presentation 2. Yeah. Everything's on GitHub, so like you don't need to write anything down or anything. Just it helps to follow along. And also there's also SQL things called .sql. That's actually example code already written out for you, so that you can basically follow along and select. And when you select and detail it, you get execute queries. Like I'll show you exactly. So open up the database, and like if we open up the SQL statement clause here, going on to where the where clause, like this is the exact first example. If you select it and press the play here, it executes the query and it'll show up right here. So first, open up the SQLite browser. If you're using the computers here, it should already be pre-installed. Then open up statsclub.db database. That's our example database. And then, as I showed you before, click on Execute SQL. Open up the presentation 2 file, or this one, since we're actually moved the where clause over this one. You can use the first one has everything. So, and follow along with the content wiki. So basically, we're going on to the where clause, basically filtering. The where clause basically filters out the result set wherever the rows, where the condition on your condition statement either returns false or null value. So, for instance, in this here is select columns from a table where we have some condition operating. So, like for instance, what's Stats Club events are social? If we select the name, type, start time, whatever we want from the table event, where type equals social. Comes up with here, where we have our BOT and our end of term, which are both social events. And it gives you all those extra information from there. In our where clause, we could have any kind of predicate. So we could have check for equality, not equality, greater than, equal to. You can even check and see if it's null. Remember, make sure that you're checking is null, not equal to null, because nothing is ever equal to null. It just is null or not null. And we could also check if something's in between a range. We could also check if a column is in a set of values. The nice thing about this here is we could also use a subquery in our in clause, so go into that later on. But we could also check like if something's like some search, like some basically it's very much like globbing, but it doesn't have the same rules, but so it basically searches for something like this expression. We also have exist, where we could do basically a subquery and check to see if that query exists anywhere, and in which case, if it doesn't, then we just filter it out. So like predicates, where we have, so for instance, for here, where it has like here, in there we could have a dash means any type of character could be at that point. And the $sign means a 0 or 0 or more characters of any type in that. So for instance, for Stats Club members that has a name beginning with F, if we select star from a member where names like capital F and $sign there, if we do that, then it looks for everything that that has an F character at the beginning and any number of characters afterwards. In which case, we return this guy here, Fred and Francis. Operator modifiers, we could also do it up so that we can have many conditions available. So, like for instance, any kind of these operators were not equal to, greater than, less than. We can also change it up so that they have so all the conditions of that column is equal to or less than equal to whatever is true for any or all of that conditions. So for instance, any or some returns true if any operator, so if any operator in that list is true for any event. So like if a column is true for item 1, then it exists. Then it returns true. If it's true for item 5 but not true for item 4, it still returns it. All does it the exact opposite, where it's if it only returns it if the expression is true for every item in that list, in that tuple. Okay, yeah. So for instance, select from a table where a column name is less than all of where, and then the brackets there we have a subquery returning at most exactly one column. So for instance, what are the expenses for non-social events? This all operator, all and all, any or some, is not implemented in SQL, so that's the reason why it's not on the examples. But if we did have it, it would basically be along these lines here, and return something like this here, where we basically select everything from expenses, where event is not equal to where the type is not social. So we would basically do a little search for find out if which events are social, and we basically make sure that if this event is not equal to that list, subquery list. And as you can see, it gets all the educational events right here. Any or all operators, basically, we could chain many conditions up together. So we could select columns from a table where some conditions true, another conditions true, or operators. So we could have very complicated expressions here. The brackets there basically tell you which one has precedence. So this one, make sure that this condition has precedence, and make sure everything goes along those lines. Same thing as any other computer language. So, like what stack club members has a name with the second letter as A or ends in B. So, select name from member where like, second where it has second letter. The first letter is any kind of character. The second letter is an A, and the $sign there. So express sign is for zero or any number of characters. And same thing here. Name like, that has the percent sign, and B that says that it ends with B. Like any number of characters, then there's a B at the end. In which case we get my name, which has a there, and here, this an A here. All these have A's until this guy here, where it ends in B. So it gives give you an idea what exactly it does. So little tiny quiz. Where clause? What events for Stats Club are introductory talks? Introductory talks starts with the string intro. So just try and figure that out. We'll try and help you out along the way. So if you have any questions, just raise your hand. Is it going at a good pace so far, or do you want me to slow down, speed up? For the all, I'll just ignore this part. Select star, this star basically means everything from the table expenses, where event is not equal to, so like the first entry here, the returns, is not equal to this value. If that returns true, then it's so it's not equal to like BOT. If event is not equal to BOT, okay. Then event is not equal to any term. But if that both those things are not true, then it basically says, okay, the whole thing is true, then we could have that one. We could have that row here. But if one goes like if events not equal to BOT, then that's false. Then that's false for one of them. So that returns false for everything, and that condition returns false. In which case, that event BOT is gone. That row is not false again. Whenever this here returns false or null, it will eliminate that row. What? Yeah, it filters it out. Yeah. Yep. That's real. That's what I need. I'm going to continue on for next one. And so we select name from event, where name is like intro with that percent sign at the end. Gives us intro to Hadoop, intro to SQL, when we basically try to do it as one whole thing, and basically where we break it up into two parts. So next, try it again with what stack club members has the first name starting with a letter between A and G. So basically you just look for use between operator here. Yeah, believe so. Yeah, you use the, like, as kind of give you a hint right there, use the between operator. So. So if you use between operators, we'll use the raise the column name between, and then your bracket values in that like in the table. And it even has, the table even has examples. So. Like in between is a totally different operation. No, you don't need no word. That's not the word. Like only use like only use the % sign and the underscore when using like functions. This one you're actually using like function, trying to use the main function. So you go back to the table, use the example there, and try to use it in that way. this one, don't use light. Yeah. Okay, I'm going to go on. So where names from members were named between this A and G. This basically looks for every name and finds out if they're between the ranking system between A and G, which basically makes everything A and G. So basically Austin here gets on there, and same thing if we have any Georges or anything like that, but we don't. So it returns this table here. So next we're going to go to the group by clause. This is where we could do aggregation based off of certain column types. So we group the table by some columns, or even some tuple of columns, and applies a function to each group. In the select portion, that's where we basically tell what aggregation function we're going to use for there. So as you can see, it basically think of this as a table, and we're partitioning up into three groups. Like say this has, there's three groups. Like there's a blue, green, and red group. So it basically partitions up, finds out which one it groups up into, and then we could do, like say a count function, find the number of rows for each one, and we'll turn 4, 3, and 4 for each one here. So we basically do a select our columns, and then you could add aggregation function. You could also do expressions as well, where you basically column, and then for group by column, you basically select the columns you want to group by. You could only use the columns. You can only select the columns that's already in the group by clause. Otherwise, it doesn't really understand what's going on. So if you want a column from a table in the select clause, you have to use in the group by clause as well. That's mostly so that it doesn't really make sense if they're not in the same order, if they're not in the same group. If group 3 had a column with a 3 in there, how would you reference that column? How would you reference that column? Because you don't know which row is which. That's not really this common throughout each group. So that's the reason why we have to have that. So every time, so when we can only select the columns that were named in the group by clause that are a part of the permanent table. So just remember that. Aggregate functions, as in the earlier presentation, we had aggregate functions. There now since we could group by those columns, we could actually aggregate over those, which gives us a lot more range of possibilities. So if we could aggregate over the groups that we're grouping by. So we do counts, do averages, max, min, values, sum, and for strings we can even group concatenate values up together. Other implementations of SQL can also do other stuff. The biggest one I found out is Postgres SQL, which could do a lot of stuff and has a lot of extensions. But for SQLite, these are functions we have right now. We could also, there's also extensions that you could add on to it, and it does, that extends the number of functions we could use in Aggregate Functions. So what are a number of each type of event for Stats Club? So what we do is basically we select the type, and we do a count, and we count star. For now, I'm going to basically rename the column as number of events, make more reference. And from event, we're going to group by type. Notice that type is here, here, and here. Basically, you can only reference in the select statement if it's in the group by clause, if it's part of the permanent table. So just remember that. And we have 6 educational events and 2 social events. So having clause is very much like where clause, but you could have aggregate functions in there, so you could check to see what's happening. So yeah, we could have, like I said, so for all the group by all the where statements we had before, they are equally valid. But now we could actually have aggregate functions in our conditions as well. That's the advantage of having. So, for instance, how many Stat Club members are in each major? Where the major has at least 2 members. So we select a faculty major and do a count. From where a member, we're grouping by faculty and major. Having basically, and the count, having count star greater than greater than equal to 2, basically only make sure that the filters out only majors that have greater than 2 members. So as you can see, XI, applied math, all these values here are greater or equal to 2. Group by clause with rollup. Rollup is really nice for presentation purposes, where you basically want to aggregate over not only the group by statements, but like the subgroups within that in that tube of columns. So you could have like we could have aggregate over our majors, and we could also aggregate on the total altogether with our roll if we use a rollup statement. SQLite does not have this. Doesn't have it inside this language, but other languages do. Like MySQL has it. I think Postgres has it too, but I'm not 100% sure. This, yeah, as I said, great for making reports with subtitles, subtotals, and totals. So what we do here is basically select like our regular group by statement, and in the group by clause, we end up with rollup. Some implementations of SQL uses cube instead, but it pretty much does the exact same thing. So, for instance, what are the number of Stat Club members in each faculty and major, including the subtotals? So, select major, faculty major, and we do a count from member, group by faculty and major with rollup. If we could implement this in SQL, this would how it would return. So as you can see, it has one econ major, and then it does a subtotal right here of art. So total of all art all members in art, which has only 1. And same thing with math. It does it all. So same thing. It does it for each major. And at the very bottom, it has math, none. So that's the total for all math. And at the very end, it has none and none. That's the total for everything in general. So, little quiz. What's the attendance for each Stat Club event? So we're basically grouping with the attendance table. So, yeah, try that out for a couple minutes. I'm just going to get something quick to drink. Be right back. Anyone have any questions? You could compare strings. It does that alphabetically. So that's the reason why.
Just how we check first.
What?
Just check to get first factor.
That's, you're talking about between, right? To finish up this, you could just do. Okay. So basically, we're selecting the from this one here. Basically, that does a comparison. It's the same thing as between 0 and between 5 and 3 or 5. It just basically does a search. You can compare strings of where one string is greater than another based on the alphabetical list, and it does the same thing here.
Well, why compare
It's comparing, making sure that each one's between. It's the same thing as basically checking if the name's less than. It's less than A, less than or equal to A, and less than greater than or equal to G. It's the same thing. You can do the exact same thing with changing that. Okay. SQL in general, but using SQL Lite to teach is the easiest way of just giving the database work on. Like for instance, all the other SQL implementations don't have it as a single file. It's on a server, usually on a server. So, yeah. Yeah, if you copy paste that, it's yeah. What else is here? The group by statement. Well, if this select statement references any other table, any other columns, so basically this here, there should be no number. This actually how many is this person went to? So this is start with the first
Okay, I'm going to go on. It's like 12 minutes on that. So if we select event, count star as tenants from the actual table of tenants, and we group by the event, we would get here basically 12 for BOT, EOT is 18, and everything else. So next we do joins. Sometimes we need information from multiple tables, and to that we need to join up tables together. We could do this in a couple quite different ways. Cross join, where basically we get the Cartesian product between two tables. So if one table has n rows, another one has n rows, if we do a cross product between those two tables, we would get n times m number of rows, which is quite big. So that's why it's hardly ever used, but it is occasionally used. Inner join, where we basically join up two tables on some join predicate. This is basically a little bit what this is basically the theta join kind of thing. Inner join basically does it so that if it ever returns false, it basically doesn't join up that table on those two columns based off of if it returns false or null. However, header join, it joins it up if it matches up with it matches up when it's when that condition is true or null. So like first inner join, it only joins it up on where that condition is true. Header join, when it joins it up when that condition is either true or null. So the left header join, where basically where the left-hand side can be where left-hand side basically is returns everything in that column. So the right-hand column could be a null. Right join basically keeps it so that the right column, right realms column, it returns every row from that column. and the left-hand side could be null. And a full outer join basically keep records from all tables up together. Natural join, we could basically join up tables based off of the same columns, where the columns have the same type and same column name. So cross join, there's two different ways of doing a cross join. We actually spell out, select the columns we want from table cross join another table. We could also do the same thing by using a comma. I think cross join is actually a better way of showing it, because that actually tells you what's doing, so it's a little more readable. So suppose we're creating a games tournament between Stack Club members, and every member, and we want every member to play each other member once. We can create this table by basically selecting name as a player 1 and another name from player 2, where we're basically joining up our cross-joining our member table with member table. Because, as I stated in the first lecture, presentation, we could actually reference the table with a dot. So we're making an alias for member as M1, and same thing with member as M2. So that way so that SQL knows which table we're actually referencing here. So this way, this is one of the reasons why you kind of want to, if you're using multiple tables, you want to get aliases so that there's no complaints of what table it's trying to reference. So if we do this here, as you can see, we basically for my name here does everybody in Stat Club, and so on. But as I said, as you can see, this is not quite what we want. So like in this one, we have players playing themselves, and where roles also where we're where player 1 and player 2 is switched. So we don't want that. So what we could do is basically just do a where clause, filter out those values. So it does do a cross product, but then we could filter it out. If we do that, we get a much more organized table, and it returns a lot less values. And this is basically what we want if we were trying to go for that condition. Inner join, where we basically joins up two tables where the join condition is true. So we want to discard it when it's either false or null. So we select the columns from our table, and then inner join our other table, and from here we use an on condition. We're basically on where we have some condition where when that's true, then we join up that row with that other row from another table. So the on clause, we can specify join condition. We can even have a set of multiple conditions where we connect it by and or. If we have columns with the exact same name, we can use using, in which case do it when they're basically when they're equal. Some implementations of SQL actually use can formulate the on condition of the on clause right from the where clause. This is usually done by the SQL implementations that you have to pay for, like DB2. It gives the same, usually filtering and then doing cross product and then filtering by some where condition gives you the exact same results as using the inner join. However, inner join makes it a lot more efficient, and basically it helps out process the query. And if it's a very long query, that kind of helps out quite a bit. joining two tables together can be very time consuming. For instance, the previous table we had before, if we did the exact same kind of condition, we could use the inner join, and where basically our theta is greater than or equal to. When it's greater than. So basically, we select our players. Then from our member, where we're inner joining member onto a member again, where the first one is greater than the second one. If we do that up, we get the exact same table as we did get before, and the exact same length. So next, how many events does each member attend? So if we basically do this up here, so how many events does each member attend? So we're basically joining up member with attendance. We're grouping up quest ID and member. So we do like first select our name, our count, and rename that count. Group by our name, and for here, just for presentation purposes, I'm ordering it by our event attended, our account. So as you can see, it gives everybody that attended at least one event. However, if a member didn't go to any events, that didn't show up. But if we use editor query, we can see if that changes. Editor query basically returns all rows for one or two of the tables. We're basically, when that condition returns null, it still keeps it into that table. So we could have basically left join, where it basically make sure that we keep everything from the left-hand table. Right editor join, keep everything from the right table. Full, basically keep all the rows from both tables. Only left is implemented in SQLite. So what are the names of Stack Club members and how many events they attended? So if we do select name, count, from member as left editor join, our attendance table, where with quest ID is equal to the member. If we group it by our name, we could order, and later on just order by events attended to show you the change. We give, I didn't unfortunately attend any events apparently, and so does James Fox attended no events, but otherwise those two people would have, everybody else would be on here. So natural join, where we join up conditions and lets the server decide the join conditions across the tables. So we didn't, for natural join, we don't need to specify the on condition. Just basically tries to figure it out. Okay, this looks like it should be right. That's the reason why you want the columns at the exact same values, exact same name and data type. So, like for instance, what names and duties of Stack Club execs? If we select from the exec table, name, position, and from the exec position, our duties. If we join up exec as E and natural join exec positions EP, we would basically get up this here, where it basically has my name here as president, and these fake people, and the various positions we have, including all the duties. So next, for our quiz here, do a little bit of joining up tables. This table here, this here just goes you to show what kind of what the database we're working on, so that it shows you what's happened. This is like a quick reference to show you how the database is structured. So the arrows basically saying this column references this column, and so on. It shows you all the various tables. So what are the email addresses and phone numbers of SAS club execs who are in charge of organizing at least one event? So basically, we basically need to join up execs and our event table here, and need to figure out the addresses and phone numbers of execs who are in charge of organizing this right here of at least one event.
It's just the syntax. Just
Have you ever seen something like that before?
yeah. Email address is that. So you can take yeah. I don't know, like, yeah, it's just like, that's true. But it's going to be like that, like, almost yeah, I guess I'm going to do that.
If you have any questions, just raise your hand.
Yeah.
be nice, but at the same time, I didn't really specify it. So. Actually, that should work because there's no thing in common, so that should work. You don't need to have, so the L dot, the table dot is only needed when there's confusion, but there's nothing in common. You only need to do the table dot name if you use the name, because there's name for event and name for exact. So, oh, yeah, there's so it knows, if you say organizer, it knows that you're only doing that. You're only doing the no. What is it? What's that? Let's say, what's it? Oh, it's a column. What you want to do with this column? It has to be.
Okay, I was going to go on. What?
Oh, that's just from. This. So that's the guys. Yes, because you, yeah, that's this. Email, just get away out. That was my first items. Like, for example, this can make it goals. Like, usually we got this, there will be two of them. That's just go to the statement from.
Yeah. So going on. So you don't really need the distinct, but distinct basically removes all the duplicates, and we just so exec.name, exec.email, and exec.phone. From exec, interjoin event on where quest ID is equal to the organizer. So this basically gives off here. A distinct basically removes all the duplicates. I didn't really specify that in the question, so it was up to you. I just had that in there for shits and giggles. So go on to subqueries. Subqueries are like, we can contain queries inside of queries. So like Inception, you could go deeper. These subqueries are contained in the round brackets. There's basically two types: non-correlated and correlated. Non-correlated queries basically don't references. Like it could be contained by itself. You could actually pretty much run the subquery by itself and be no problems. Correlated subqueries actually references the outer query, so you could do like some fancy things in there, but for every row on that table, it actually executes that correlated subquery. You don't really want that done very often, so it has to be run. So non-correlated, run independently of the larger query. You could execute it by itself, and correlated subqueries is run concurrently with outer query, with outside query of it. So it can't be run by itself. So non-correlated subquery, any valid query within a query that it could be within the from, where, or having clauses, and it has to be encapsulated with in the round brackets there. So, for instance, what Stack Club execs are in charge of making posters. If we select poster from event, select the poster gives us the quest ID for the one that has basically in charge of doing up a poster for the event. And then we do a select name position from exec, where quest ID is in that subquery list of all the quest IDs that have done up posters. We get basically various club members and their position that have ever done a poster for event. Correlated subquery makes reference to the containing subquery. As I said earlier, these can be done in the select, where, or having clause. So if it's in the select clause, it can only return one row. Otherwise, it gets very complicated. Yeah, and so you can only return one row. And then where could basically, and where and having is very similar. So, for instance, what majors are the current current Stack Club execs rolled in? The member table has the information on majors. but exec has information. But has exec has information on who wrote execs and who are and the information on them. So if we do a select name, and if we do a subquery where a correlated subquery where we select faculty from member as where our request ID is equal to where the okay. Okay, I want to try and remember why I did this again. Select member. Okay, yeah, we're basically where we're basically referencing the member and table. So basically, it looks for where the quest ID for exec and member are the same, and finds out what faculty they are therein. And same thing with major. And if we execute this, we basically, for all the execs that are also members, we show up like the faculty and major. However, for some of them, they're not currently signed up as members for some reason. They return a null because we don't have any information on them. And when it does that select statement, it returns nothing. And so in which case, it inserts a null value there. So for correlated versus non-correlated, correlated is dependent on outer query. Non-correlated is independent. Correlated is executed concurrently with the outer query. So for each row, that subquery has to run, which is really expensive. So that's the reason why for execution, you try to basically, you want joins. If you can't do join, do a non-correlated subquery. If you really have to, do a correlated subquery. So, little quiz. Where can a non-correlated subquery be placed? This should be also on the wiki. So where can somebody just raise their hand? Yeah.
From where?
Yeah. From and where and having. Yeah. And where can a non-correlated subquery be placed? Nope. There's one difference. Can you use a non-correlated subquery in a from statement, in a from clause? No. Oh, sorry. Yes, that's main mistake there. That's supposed to be a correlated subquery. So, where can a correlated subquery be placed? What? Select and having, yeah. I'll correct that next time. So using a non-correlated subquery, what are the names, locations, and description of events that serve pizza? So we could break the problem into two smaller pieces. What are the events that serve pizza? And only retrieve values from the table event that where the name of the event matches those values. Yeah, try that out for a couple minutes. Yeah.
they can charge these companies, then the cost of each should be, in the account. So if you go to so yeah, they should be the cost of each should be. That's what I'm saying. So that's what we do.
Description for the events? Yeah. Where is it? Oh, each of them are smaller. Oh, wait. If you look at the supposed to start time and time location budget, should it be in there? It should be in there. Yeah. I messed up for a second.
This is a slightly hard one, so don't feel too bad.
This is the hardest one, though. I wonder if we should skip that. From that one, I'm just going to go close to it. I'm not just like yeah, I'm not going to use that one. Try that one. That one actually gave an explanation to why. Yeah, you're in the here, the database. Yeah. It doesn't include the description for the units. Oh. Okay. Just the units. Okay. I'll have to change that. If you have any questions?
I'm going to go on to next, okay? So if we select event from expenses, where expense is pizza, we would get this kind of table. So from here, we could actually use this to bring it up to a new one. Then we retrieve, if we want to retrieve only values from the event table, where event matches these values, we select name, location, description. From event, where names inside of that query, where select event from expenses, where expense is the pizza, we would get, we would basically get our BOT, the first SQL, and 2 prof talks. Alternatively, we could also use a join. So if we join up that subquery with an inner join for event, where that event is equal to the name, that's also equally valid, and we get the exact same thing. So set operations, we can combine rows up together and do operations that way. So you could use basically sort of like stacking another table on top of another table. So we have to have the same number of rows, same number of columns and the same data types for all the rows. If you really want to basically have it so that another table, we can have a different set of rows, you could insert a certain null value in there, in which case for every row it would have that null value. So we could basically use unions, where sort of like a union of a set. Same thing with the intersection, where basically intersection is basically where those 2 tables have the same entries. Then we can work. That returns only just where the common ones are have in common, and the difference basically taking away one set from another. So union operator basically puts one table on top of another. The union, when you have the condition all there, that basically sets it more into bag semantics. So even if it's repeated several times, it repeats several times. If you just keep union by itself, I believe it it will return like just in a kind of a set operation kind of way, where basically it won't repeat distinct values. So suppose we want to contact everybody involved in the SAS Club, execs and members. So we need to find names, email addresses, and phone numbers for all members and execs. Members don't have phone numbers. So if we select name, email, and null as phone, because member does not have a phone number, and we union that up with exec's name, email, and phone, we would basically get this here, where we basically have everybody's information of how to contact them. Intersection, where we basically want to return only values where they have in common. So rows must have an equal number and type value. I don't know. Oh yeah. Sorry. Result sets must be equal in the number of columns. I forgot that number of columns in there, and the type of attributes. So first time making this presentation here. So what Stack Club execs have also signed up as Stack Club members. So we basically try to find the name and quest ID from member, intersection of where name and quest ID for exec, and we have that information right here. So, and same for accept, we basically return the first set minus the other minus the other result set. So just exec, except returns kind of the set theory kind of minus, where it doesn't really care about the number of duplicates. But if you do all, it doesn't puts in the bag semantics, so that it basically, for every one there, it eliminates another one there. So like if you have several rows that are like exactly the same, and it has and the second result set has like 1, it will only take away that one result, only that one row. If you do except, it eliminates all of them. So what stack club members are not execs? So if we do that up, we basically, if we select name, quest ID from member, where we're taking away our name and quest ID from execs, we basically have all the members here who are not signed up as execs for Stat Club. With clause, we basically, with a with clause, we can make a non-correlated query look like a table in the executed statements. This makes it look a lot neater and fun, neater and cleaner. So you basically, and much more understandable. So it's really helpful. This is basically how it's designed. So with right before even the select clause, we have a with the subquery name we want to name it as. We could have an option of naming our columns. That's why the square brackets are there. That's just to say that this is an optional statement. And where we have say as, and in round brackets we have our subquery right there. If we want to do several, we after that subquery do a comma, and do another subquery with the same kind of procedure. After everything, without that comma, we could do our regular executed statement. So say we're doing a report for Stats Club detailing events, budget, and expenses. So say with cost as event and expenses, we basically select event, sum our price from expenses, and group by event. So that would basically give us the expenses for each event. And now we're just basically selecting the name, type, budget, and expenses that we do up with the subquery from event. Inner join the cost where the event name is equal to the cost, the name in the event in cost, the subquery cost. So if we do that up, we have this here where we basically, instead of for expenses, we have just itemized list. We have the total expenses for each event, and also tells you what kind of budget there is. So this one's really hard, and we don't have much time, so I'm just going to go through it. Like in this hypothetical scenario, we not only want to provide MathSocket provides a cap for social events based on the formula of basically max of 250 and with a formula of number of MathSocket event members times 5 plus membership fee, which is $2. So max of 250 versus number of members times 7. So if we break it up to smaller problems, what are the total expenses for social budgets, and what's the max budget for each social event? So like what's the social total expenses for social events, and what events are social events? So these are the questions we want to make and design up queries that way. So if you're trying to tackle a big problem, break it into sub-problems, make queries for those sub-problems, and join up those tables up together. This is the formula I'm basically trying to go with, and we're basically trying to find a cap of social events with that formula and find the max value between these. So first part, for total expenses, try to find the sum of the expenses, filtering out non-social expenses. So what events are social? we want this here. So select name from event where type equals social, or BOT and end of term. What are the total social expenses? So trying to find the sum of the prices from expenses where event end is in that social in that query that we made up earlier, where it should be only give BOT and end of term, in which case gives us $219. We could also join up tables, the events and expenses table, and filter out social events this way. Either or is fine. Each give pretty much the exact same thing. So basically from here, we basically have social cost, where we basically find our expense. So find the sum of each price based off the where each. Basically, we're doing up the query here to find the total of social expenses, and here we basically try to find a social budget, and then you're going to use a select statement. So next part, we're basically trying to find our budget. So we need to calculate the number of MASOC members times 7. So basically, how many people are in the math faculty? So we basically do a count of members where faculty equals math. That's 33. So what's the result of the formula of this here? We want count times count 7, where the faculty equals math, and we get 231. And so what's the max of this number and 250? We could basically join up this table with just a selection of 250. So should we have the result of this subquery should give the rows of 231 and 250, and we just basically this selects the maximum of that value, in which case 250. So we join up all this together with social cost expense as that subquery right here. We're basically finding the cost, social expenses, and here we find our budget. And right here, we basically do a cross join of those two rows, which return only one value. So social cost, cross join social budget, and where we social budget minus expense gives us this value right here. So we're under budget by $30. Case expressions similar to sort of like if statements, where basically it's executed where that if statements could check for every row. So case where column, the brackets here just means that this is an optional. If you specify a column, in the condition statement, you can just say what kind of results that column should have, and if that's true, then we return results of the result. So basically case, and when condition, then give it a result. At the end, we can have an else statement as well, and name it all off by using the word end. So yeah, the result can be of any data type, as long as they're the same. A column should only return a data type that's the same throughout. So but we could use any kind of return any data type as long as it's the same for that column. Case expressions performed by themselves in the select statement or within could also be done within an aggregate function as well. If we do an aggregate function, we could actually do neat little things inside that aggregate function. So yeah, you could basically return change a string into some value that we just decide on. Like, okay, for pizza, I want to return a 5. For cookies, I want to return a 3, or something like that. So that's that's one of the really neat things about it, and we could just do aggravations on that. Suppose like we're doing a report for Matasak, but now we want to give a warning when the event is over budget. So we do something like this here, where basically with cost, we named the subquery cost and gave it the name events and expenses. The reason why I have this is because it makes it a lot easier to use, and we are using that as a select event, sum of price from expenses. We're grouped by event, so basically we are grouping everything up by an event and finding expenses for each event. If we select name, type, budget, cost, expenses, the expenses we have, and when the budget is greater than the budget is less than the expenses, then that's a negative value, and then we'll return over budget. Otherwise, just give a null value and end it as a warning. So if we join that up with cost or cost event, we would get something like this here, where basically it shows you like what kind of budget we have, and if it's ever over budget, even by a slight amount, it gives a warning of over budget. Otherwise, it does nothing. So I'm not sure how much time we have left. I'm just going to go through it, okay? You don't mind? Or do you want to do these little quizzes? Do you want to do these quizzes? It's okay? Yeah, it's near the end. Like, we're actually over time, so. Suppose we're interested in healthiness of food options in Stats Club, and we're trying to get some value, some opinion of like healthiness of our events. So like if we have donuts, give a -2, but if we have like veggie platter or something like that, give like a 3. So what average them up for each event and try to see what happens. So select the average of where the case where event is in those values. If those ever come up true, that returns that number, corresponding number, and referring expenses, and we have a negative score of 0.75. Order by clause, we're nearly done. Order by clause rearranges the rows of a result set according to a table of columns. So we could order columns by some values. Ascending basically is the default, where it goes by by the lowest value first, then higher values from there on. Descent does the opposite of descending values. As it shows there, the square brackets, that's supposed to mean that's optional, and that's saying that it could either be ascending or descending. So what's the membership list ordered by name? If we select name from member and order by name, we would get this query right here. And next is limit clause, where we basically restrict the result set to the first so many rows. So select the column from table where we did usually, and limit the number of, and give limit of number of rows. Number of rows here should be actually given as a number. Same thing with row number. So we could basically offsets it from the very first. So you could do like, I want 20, but I don't want to include the first 10. So what are the first 10 members ordered by name? So if we order the query by name, then limited to just 10, we get this value here, this table up here. And I'm just going to go through this again, quickly. What are the top 10 priced items in expenses? So if we select expense and price from expenses, and we order by the price and limit to just the first 10, we would basically get this value up here. So remember, this keeps in, it doesn't eliminate distinct values, so if we order cookies several times, we get it up several times. So that's the end of presentation. I didn't really cover how to create a database, how to create tables, constraints, or indexes, or even views. You could do a lot of that stuff up with SQLite browser. Our next SQL event is Intro to Hadoop, which is on March 25th from 2:30 to 4 o'clock in M3 3103. Here are some of the references. Actually should. So, like learning SQL, there's also CS databases courses offering you Waterloo. And there's also a few Coursera courses, Introduction to Databases, Getting and Cleaning Data. That actually tells about how to use R with SQL. So that's it. Now we're going to basically go over to MC Comfy, and we have donuts and other unhealthy things, and well, do have one fruit platter. So